everyone, and welcome back to my channel. This video is application of what we covered in the previous video. This material really builds on each other, so I would definitely watch that first. Okay, so propositions has one and only truth value. Sentences such as 5 is a prime number is a statement, same thing as proposition. Those are synonymous. And even 5 is an even number, which is obviously false, but it's a proposition nevertheless because it's the type of sentence that is either true or false. Okay, it has that type of binary type of a truth value. You need to know truth tables of conjunction, which we went over that in that video. It is quite demanding, conjunction, which is and connective. It's true only once out of 4 cases. And disjunction is true 3 times out of 4. If one of the disjuncts is true, it is true. And if both are true, it's true. That's not a requirement though. It's true 3 times. And then negation, truth tables goes like this. So if the original statement was true, such as 5 is a prime number, it's true, right? Then its negation, 5 is not a prime number, would be false necessarily, because that comes from the definition of a proposition, right? It's either true or false. If the original was true, its negation has to be false. And if the original was false, like 5 is an even number, then 5 is not an even number, has to be true. All right. So here are all the rules and laws that you need to know. I would definitely do truth tables of each and every one of these. I'm going to do this one and 2 of the DeMorgan's here, but all of these are super important because they're very similar to the laws of arithmetics, right? Addition, you learned, was commutative, and that's very similar to these laws. Otherwise, you wouldn't be able to do mathematics. P or Q is the same as Q or P. If 3 plus 5 wasn't, if you didn't know that it was same as 5 plus 3, math would be hard, right? So this means logical equivalence. And that means that the truth table of this looks exactly identical to this. And we'll do that in practice so you'll know what that means. Here, this is very similar to double negatives cancel each other, right? This is negation, negation. They cancel and you have P. So P is equivalent to not P. And then if you had 4 of these would be the same. If you had P, not P is equivalent to any odd number negations. Okay, so then you have commutative or commutative and, then you have distributive or distributive and, then you have distributive and over or, where you put this here and then this here, and then you have 2 of the disjuncts. So same thing for or, over, and then 2 of the DeMorgan's. We're gonna do truth tables of this one. What are we trying to see here? Is the left side, they're basically arguing that the left side is logically equivalent to the right side. And let's see. Okay, the only knowledge that we're gonna use here to check this is the knowledge of when is disjunction, which is or connective, true, and when it's false. So it is true when either of the disjuncts is true, when both of the disjuncts are true. It's false only when both of them are false, okay? So that's the only knowledge that we're gonna use here. We're gonna apply a few times, but that's all that you need. Okay, so you have 3 different propositions here. You have proposition P, you have Q, you have R. Those are just 3 different sentences that are statements. So such as P could be 5 is a prime number, Q could be 5 is an even number, and then R could be 7 is an odd number, okay? So 3 different propositions, and you have 8 rows instead of 4 because there are 8 unique ways to pair them. And you need to examine every single possibility, okay? So these are unique, trust me, because when all 3 are true, that's this row. When all 3 are false, that's this row. And you will not find a repeat because you have 3 propositions and you have 2 choices, true or false, right? So you have 2 raised to the power 3, 2 cubed, right? So that's why you have 8 rows. Okay, So we're gonna treat, first we're gonna get truth values for this, and then we're gonna get truth values of the left side. Once I get truth values of this little capsule right there, I'm going to treat that as one proposition, one unit, one whole unit. Maybe I can even name that T. I don't know why T. Maybe N. That's better. And then P, I will then just think about P or M, right? I will treat that as one unit. So first I'm going to get truth values for Q or R. That's here. I'm going to cover up everything that I don't need to look at. I just need Q and R. So I'm going to cover up P. Okay. And you can cover that with your hand when you're doing your homework. Okay. Well, I know that it is true more times than it is false. So first let me get when it's false, and then I'll know everything else will be true. So it seems like this is the only place where it's false. Okay, so I go into my robot mode, everything else is true. Now I'm going to cover up everything else except from P and this. So this I'm going to treat as one unit, and then I also need P. So I'm gonna uncover that and then cover Q and R. I'm no longer looking at those individually because this is, I already got the truth values and that's the only thing I need to look at, okay? So I know that, again, I'm working with OR, working with disjunction. I know that it's false only when both of the disjuncts are false. And that happens, it seems like it only happens here. Okay, so it is false here and everywhere else it is true. Okay, so I have truth values of the left side. As I told you, when you say that this proposition, this statement is equivalent to this statement, you're saying that when you do the truth tables of this, it will be exactly identical to the truth tables of that. And let's see if that is true. So for the right side, now I'm going to take P or Q. Okay, so I need P and I need, oh, that's R. I need Q. And everything else, I definitely don't need to look at these. Okay, so P or Q, it is true here. It is true everywhere except from when both of them are false. Fill out false first, and then everything else is true. Okay, now I uncover R, and I cover P and Q individually. Definitely don't need to look at those because I'm treating this as one unit now, okay? This is one unit. It can be G. This can be G. So now, only thing I'm observing is when both of R and this thing is false, okay? And it looks like it's the last row here. Exactly what we wanted to prove. The truth values of this statement that you have in the left and the right statement are exactly the same. Two tables look the same. Therefore, these indeed are equivalent statements, okay? There you go. Now we're gonna check. I strongly urge you that you check each and every one. These are easy, but definitely check those using truth tables, just like we did here. Notice that we just used our knowledge of when is or disjunction true and when it's false. We used it a few times over and over again, but that's the only thing you needed. Okay, so DeMorgan's laws, they're gonna come up not only in this class, but in other classes as well. It's gonna become your second nature, and it won't become your second nature unless you do it a lot. So definitely do it on your own as you're watching me and do it a few times. Okay, so this is DeMorgan's laws for not and, okay? So notice here that you have and then it turns into or, okay? Remember that. Both of the DeMorgans are gonna do that. They're gonna flip. You're gonna start with and here. What you have here is P and Q. Negation of P and Q is equivalent to not P or not Q, okay? And we're gonna see if the left side is equivalent to the right side by seeing if the truth tables here are exactly identical to truth tables there, okay? So let's start solving this. P and Q, I'm gonna start again with P and Q, and then I'm gonna do negation of that and treat this as one unit, one whole capsule, okay? So P and Q, I know that and is quite demanding. It is only true when both of the conjuncts are true, false everywhere else. So I write it like so. And then negation of this, now treat this as if this was P or M, right? So negation, when original statement is true, its negation is false. And when original statement is false, its negation is true. So you simply flip this and you get its negation here. If you have true, false, 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 you get false, true, true, true. Okay, so we got the left side, and we're gonna see if we get the right side to look exactly like this. Okay, so first I need to get not P, which is false, false, true, true. And not Q, which is false, true, false, true. And now I'm gonna get OR. And I know that OR is not very demanding. It just needs that one of the disjuncts is true, or if both of them are true, the disjunction is true as well. It's only false when both of the disjuncts are false. So true everywhere else except from there. Now, notice that truth tables are identical, so therefore these two statements are logically equivalent. Now let's check the other DeMorgan's law. Let's start with P or Q. It is true everywhere except from when both of the disjuncts are false, and the negation of that is simply flipped. And not P is false, false, true, true, and not Q is false, true, false, true. Okay, not P and not Q. We know that and is quite demanding its conjunction. It's only true when both of the conjuncts are true. That happens in the last row. Everywhere else, it will be false. Okay, and here you have it. Truth tables of the left side is exactly identical to the truth table on the right side. So these two statements are identical. So those are two DeMorgan's. Moving on to the next topic, it's very simple. Tautology and contradiction is just vocabulary. Tautology it's a Greek word. It means saying the same thing or saying what's already known. So I have boring emoji there. And the reason why is because it has or here. Remember that or disjunction, it demands that only one of them is true and then it's true. Okay, so when you have P, a statement, and its negation, and you have or there, okay, if the original statement is true, its negation is false, and then when you put it together with or, one of them is true, and that's enough for disjunction to be true, and then here, it's true again. So it's always true. It's repeating the same thing, okay? So here you're saying either 5 is even or 5 is not even. Well, one of them has to be true, and that's all you need when you are working with connective or disjunction. And negation is the exact opposite. It's like always lying. Here is your screenshot if you want to take it. What this is doing is that it's and connective, and you need both of the conjuncts to be true for the whole conjunction to be true. And this has no chance, because when you're working with one proposition, if it's true, then its negation will be false, necessarily. Then when you put them together using and connective, it has to always be false, because 5 can't be even and odd at the same time. And that's what this is saying, right? So therefore, truth tables of this would always be false. So that's why this is a contradiction. And this is a tautology. It's always going to be true necessarily. And now let's talk about where you place parentheses, because you're going to be working with these when you have tons and tons of different propositions. You need to group them correctly. So negation takes precedent, if you will, because whenever you see negation, you apply parentheses immediately on the smallest unit, okay? It's better to show you actually. So here you see negations, you put parentheses immediately after. You wouldn't do negation here and then this whole thing. Negation applied to the smallest possible little unit. Then the second is and connective or conjunction. Then you see and then you apply that here. You wouldn't say this or this at all. You would say, first you would have this parenthesis written and then you would say this, right? Okay, so that's what this is telling you. And then final is or. Well, don't worry about it because if you've done this, that's what's left, right? So let's go over and do these exercises. So here I would do parentheses there and then here, but these cancel each other, right? Because that's one of the double negative law. Then I will do this, and then there's nothing here. Then I'm looking for and. I will draw parentheses there, and that's it. You have two disjuncts P and not Q and not S. Okay, that's what you have here. Second one is, again, start with putting parentheses with immediately the smallest little unit, and then look for and. So I would do this next. So I would have two of this. And this actually, okay, so the second one is interesting. So this is the final answer, by the way. I will have this link down below, so don't worry. Second one is by DeMorgan. It's equivalent, just this right here, is equivalent to P or not Q. You can check that, maybe do the truth tables of that as your homework and see what you get and put it in the comments, because that will be great practice. So the third and fourth, just like we did, first you apply parentheses with the negations, then you look for and, right? There, and then you would have three ors. And here I have drawn parentheses, here. However, you could have chunked them differently, like this and this, right? That's using commutative law. And then in the fourth as well, you could do this and then group these two together, okay? That doesn't matter, it's the same thing. So you will use these laws all the time, so try to learn this deeply because this is a building block of what's coming very soon. Hopefully this was helpful and happy studying. Bye.